Hey everybody. So this is part three of the How R thinks about data sort of lecture module. So because we had a little bit of startup issues with the GitHub SSH, if you recall, we split this across weeks 2 and 3, which likely means if you're working on the week 2 homework right now, you're starting to encounter some things that we haven't talked about in class. So hopefully this will fill some of that in. And we'll be able to talk about it more on Thursday. So no worries if you're not quite up to speed on that stuff yet. It's not your fault. We haven't covered it all. Um, in any case, so this will be part three where we're going to talk about, we've talked about what vectors are in the first video. In the second video, we talked about how to do things with vectors, pull items out using indexing, and then using subsetting, which is a type of indexing where we try and actually like filter or extract items from the vector. One thing I wanted to highlight before moving into the topic for this section 3, which is vector math and vector recycling, is actually one last command that shows up in the indexing and subsetting portion of this lecture. And it is a special character function in R where you take a percentage sign and then you type IN, the letters or the word in, and put a percentage sign after it. Now, if you type that in, it should show up as like a kind of a funky color. In this case, in the visualization, like the display option I'm using, it shows up as blue. So what in is it's a special function that takes some sort of value and then actually asks, is that value in anywhere in this other vector? So let me show you an example of what that looks like. Forgot to run all the code to start here. So first off, let's take a look again at that animals vector that we made for the first and second videos for this module. Oh, it didn't show up. Hmm. That's weird. Let's make our own here. I think there was some error with what I created. Okay, so let's just make an animals vector. So in this case, it has 4 strings: mouse, rat, cat, mouse, rat, dog, and cat. And so now what we're going to do is we're going to run this code where we take this animals vector of 4, and we're going to ask R, are these values in this other vector that we're comparing against? So let's run it and then talk about what's happening here. Okay, so we run that code and we get 4 Boolean values. It like returns a vector of false, true, true, and true. And so just visually, you can look at that first animals vector and the second vector we compared it to, and you can see that rat is in both, and dog is in both, and cat is in both, and mouse is not. And so you can see what's happened here is essentially that special in function has done like a loop or iteration, and it's checked for each value in the first vector, is it in the second vector or not? And so it essentially like saves you writing a bunch of line of code where you're like, is mouse in there? Is rat in there? Is dog in there? Is cat in there? And that can be powerful for a variety of reasons that we'll likely get to later on in the quarter. Okay, so bouncing off of that, the primary topic of this video is vector math and recycling. So that might not mean anything right now. So let's actually dig in, if I can spell recycling here. Cycling, that is cycling. It doesn't matter how to spell recycling. Let's move on. So let's create a vector of 10 values and we'll name that vector X. So here we're going to use that colon to create a sequence. So if you recall, any number colon another number creates an integer sequence between those. And so in this case, we have a vector 1 through 10. So that'll be X. Now, the way R treats this is if you add a number to a vector, it's going to add that number to every item in that vector. So if we have X is the values 1 through 10, and we then call X plus 3, we end up with a new sequence that is 4 to 13. So we've simply added 3 to all those items. If you wanted to do multiplication, we can multiply everything in X by 10. We end up with 10, 20, 30, 40, 50, and so on. So R sort of behaves somewhat intuitively in that case and does what you want it to do. Now, you can try a weird example, right? So you can say X plus, and then we'll just concatenate 3 and 4. That gets sort of like a weird wonky result. I'll explain why in a second. I think the big rule of thumb here is vector math is your friend when you're doing simple operations, right? You're adding one thing to all of them. You want to start being really careful when you're doing sort of more complex vector operations because you get sequences like the one we just produced where it's like, what is going on there? And we can understand what's going on there, but often that sort of behavior can end up creating problems for you down the road. And so R kind of does what you want when you keep it simple. And you need to start being really careful and make sure you understand what's going on in your code when you complicate it further. Okay, so let's now try, we'll just actually add two vectors together to check out another example. So this case, we're going to create y, which is going to be a sequence from the number 100 to the number 109. And just to prove what's going on here, let's check the length of x, it's 10, and the length of y is also 10. So you might have a guess as to what happens if we add x and y. Let's check it out. Okay, now we see a set of numbers 101, 103, 105, 107. I think the easiest way to show what's happening here is I'm actually going to create a quick matrix. Don't worry about what that is at the moment, but we will view it in the console. We have X and Y, and then you can see, oops, I did that wrong. You can see that new XY vector I created. And so now if you look row-wise, you can see what R actually did is it took the first element from each vector and added them together. It took the second element from each vector and added them together and so on. So 9 and 108 becomes 117, 7 and 106 becomes 113. And so in this case, that might again feel intuitive in terms of the idea that you have like this thing that's 10 units long and you have this other thing that's 10 units long. And if you add them together, you want sort of 1-to-1, 2-to-2, that type of behavior. But, and here's an example of where it kind of falls apart, like I showed earlier. Let's say we create Z, and Z vector Z is simply two numbers, 1 and 2. So just to verify, we'll call structure on the Z, and we see it's an integer sequence. It's only two values, numbers 1 and 2. So what do you think will happen if we add X and Z? X is 10 units long, Z is 2 units long. Okay, now we get another vector. It's 10 units long again, so it's the same length as X, but now we get some funky values. Let me show you what's happening here. I'm going to create another matrix just to kind of prove it. So if you are viewing the console that I just output, what I did is I made the first column as X, the second column as Z, and the third column is what happens when you tell R to add X and Z, those two vectors. And so what actually happens here is R takes Z and it recycles it as many times as it needs to until you reach the length of X. So the first case, we have the first item in X, which is 1. And then we have the first item in Z, which is 1. So 1 plus 1 is 2. The second item in X, second item in Z, both 2. 2 plus 2 is 4. The third item in X is the number 3. But there's only 2 items in Z. So it actually starts over again, goes back to the first item in the vector, which is 1. So now we're at 3 plus 1 is 4. That's what's called vector recycling. And so that's what R does when you are trying to combine vectors that are of different length. Again, that is useful that R can do that, but I think you can immediately think of ways that could go drastically wrong. So just as a quick example, let's say instead of 1 to 2, we create Z 1 to 3. So now we're going to call strz. Now it's integer. It's an integer vector of 3 numbers, 1, 2, 3. So now R gives you a warning. And so again, remember, if you see an error, it means like the function broke or didn't work. If you see a warning, R is saying, hey, we did this, but it might not be what you want. So you should at least be aware this happened because it could be a problem. In this case, the warning symbol is pretty straightforward. It's simply saying, hey, the longer object length is not a multiple of the shorter object length. It's not like a factor of the longer length, right? And then so this case that makes sense, right? 3 is not a factor of 10. It doesn't go in an even number of times. And we can look at the result if we quickly make one of those column matrices again. you can see we get sort of weird recycling, and it's difficult to envision a case where you would like would be desirable behavior. It is sometimes the case where you want something to repeat that fits in an even number of times, but this sort of thing where you Z, ends up coding as 1, 2, 3, 1, 2, 3, 1, 2, 3, and then 1 is at the very end. That's unlikely to be the type of thing you might want to do. Okay, so a couple other ways we can do recycling I want to highlight. First thing is that you can also recycle Booleans. And so in this case, we could create a quick vector of the value true and the value false, and it's 2 units long. So if we actually plug that in within the brackets to the x vector to index x, what's actually going to happen is it's not just going to apply true and false to the first and second elements in that vector. R is going to recycle that as many times as that 2 length vector fits within it. And so it's actually going to return 5 values because 2 goes into 10 5 times. And so you end up with 5 trues and 5 falses, and it returns the 5 true items. So in this case, all of the odd numbers. Same problem then. In this case, it doesn't actually throw a warning, which is somewhat unfortunate. But if you throw in true, false, and false, it does that same sort of like weird repeat indexing where it gets the first one, the fourth one, the seventh one, the 10th one, and that may or may not be what you want. We can just to check out what's happening here and visualize that again. Well, in any case, I'm not going to do that because I think this video has gone on long enough. Okay, so let us know if you have any questions. Hopefully, at this point, having done a variety of things with vectors, you're starting to feel a little bit more comfortable. Then we have one other video coming up on vectors, and in this case, on missing data. So be sure to check that out as well. Thank you.